So here's what we need. We've got our distilled white vinegar. We'll need a 1/4 cup of that. Some salt, a teaspoon of that, paper towels, nice something we can see, glass, got a bit of a wide bottom on it, and some tarnished pennies, as tarnished as I could find, about 20 or 30 of them here. So I thought I'd pull out some pennies at various stages of oxidation and reaction. So like here's one that's still pretty shiny, but there's on the ridges you see some copper oxide forming, and that's the black stuff. Here it's quite a bit more oxidation, but still some shiny parts, probably where there's wear and it's been worn off. That one's just about covered in copper oxide, and eventually you get that patina or verdigris, like the Statue of Liberty green color. A lot of people think that's copper oxide, but it's much more complicated than that. All right, so I'm supposed to put a 1/4 cup of this distilled white vinegar in here. Oh, a little bit too much. All right, and then we've got the 1 teaspoon of salt, which was a lot more than necessary. You can see I'm not really that careful. That's why I'm not a good chemist. I'm really a physicist, sort of. And just stir that around until it dissolves, or it's supposed to. Never really tried to dissolve salt in vinegar before. Of course, the vinegar is just dilute acetic acid. And there you go. It dissolved pretty readily. Okay, so I'm taking a particularly tarnished one. A lot of copper oxide, I guess. And I'm supposed to dip it in here. About halfway. For some number of seconds. This reminds me of when I was a kid trying to clean my pennies with Tarnex, which was essentially the same thing but much stronger. I think we're going to see in just a bit why later it wasn't that great of a thing to do. I'd say it's definitely lightening up a bit. All right, let's just stick that in and dump all the rest of them in. And now a little stir. I'm going to do that every so often. A few little bubbles coming out of there. I think there's a few. They might have just been connected to the pennies, but I do see some bubbles coming out. They said there might be some hydrogen gas formed. There's no doubt that it is cleaning these pennies up. All right, I'm gonna let that soak for a while. Okay, I'm ready for the next part where I'm gonna take the pennies out. I'll put half of them right onto the unrinsed paper, and the other half I'm gonna rinse really well with water, and I'll dry them out here. All right, here we go. Half of these get in here. Definitely a lot cleaner. Now we definitely want to keep the solution. That is really important. Okay, now that these are rinsed, whoops. All right, I'm gonna let these dry. If I see anything happening, I'll turn the camera back on. And I may be seeing things, but I'm hoping that this solution will turn a little blue, or is a little blue, meaning that some of the copper ions are in solution. I want more, so I'm gonna dump more pennies in there and see if I can get some more copper ions. Okay, here we go. I think I may have thousands of pennies. I really could try to get some serious copper solution here, but what I probably will end up doing is trying to evaporate or boil away a lot of the water so that I can get some more concentrated solution. All right, let's see if we're actually getting some blue or if I'm just imagining it. I'm just gonna really do this. Come back to that. So the next part of the lab depends on there being copper ions in that solution, which is why I'm looking for the blue color, because I'm hoping that you'll be able to see that. Now, if the pennies are out, it really just looks dirty. But I'm going to take this even further and try to concentrate the solution, and we'll just see what happens. Okay. Well, it's probably been more like another half an hour or so, and I could be wrong, but it seems like these unrinsed ones are more tarnished at this point. They still seem to be a little cleaner. I even see, some of this some blue stuff there. I don't know. It could be from the paper itself, maybe the dye of the paper, or maybe something. See a little greenish there. Okay, well, we'll come back to this again even later, but something may be happening. Seeing more oxidation here of some types. This is still yellow. Now, that doesn't mean that there aren't copper ions. That's the thing. It doesn't mean that there's no copper ions. It's just that if there were a fair concentration of them, then this would look kind of bluish. And I was hoping it would look blue, but it doesn't. But in the next part of the experiment, we'll see if there really are any copper ions in there. It's like, oh yeah, now there's really something. You can see some of these are even getting that patina, that green. So that's a pretty accelerated process. Of course, having that solution sitting on there all that time is why that is. Here, where we rinsed it all off, process stopped, everything looks more or less like it did, although in fact over time it will do that also. It will just take much longer. Well, I've let this sit out a couple days and a little evaporation, and it really is getting a blue color. So I'm going to continue to let this evaporate before I do the next experiment. I decided to try the process with some shiny pennies. And you can see there's some black on there. I'm pretty sure that would just be copper oxide. Well, I've let a lot of this evaporate. See, it really is pretty blue-greenish, but we'll see for sure if that's copper ions, or at least some presumption that it is when we do the other part of the experiment. But also seeing there's a lot of white crystals, which may just be sodium acetate or sodium chloride coming out of the solution because it's getting too concentrated. And over here, and maybe what these little white crystals are here too, that may just be salt. And the rest of the stuff definitely getting more patina. Well, this is pretty cool. I accidentally spilled a little water, splashed a little water on the pennies yesterday, and look at this. A lot of verdigris, and even the shiny ones definitely have some more tarnish. And over here, see, I've waited so long that everything's evaporated, so I presume there's whatever copper compound and sodium chloride and probably some sodium acetate in there. But I'm going to let this, I'm going to put some water in, reconstitute it, and we'll let it settle. We'll move on to the next part. Okay, so stir that around and try to, probably won't all dissolve, so I'm not putting in a whole lot of water, but get as much dissolved as I can. And then I'm going to let it sit and settle and see if I can draw off, or see if I can decant some of this liquid. Okay, I've got my solution. Hopefully that blue is actually copper ions. So I got a nail and a screw. So I'm just gonna go ahead and put that in and put it here. I'll leave them both out a little bit so that we can get a contrast if anything happens. Hard to see right now. And in this other one, I'm gonna put a couple little pieces of aluminum foil in. Let's see if anything happens here. Not sure I'm seeing too much yet. No, I was hoping to see those little hydrogen bubbles maybe. Yeah, we'll come back to this. Well, it looks like something is happening with this nail. You can see there's a difference in color. I really thought the aluminum would react strongly, but not much happening there. In the meantime, I'm gonna try something else with these heavily verdigreed pennies. So I'm thinking if I start soaking this stuff, I can get more of the copper ions into solution, and then maybe make more and just cycle them through and see how much copper I can get into the solution over here. And then maybe this will work better, because I'm not too thrilled about this right now. I mean, I'm getting something, but what I'd really like to see is over time if the blue will go away, showing that the copper has precipitated out. Well, we'll see. So I'm gonna go ahead and start this over again with about 1/4 cup of the vinegar. A little salt. I'm sure the exact amount doesn't really matter that much, and I don't want to use as much as last time. I think I would use maybe 1/2 or 1/4 as much next time I tried this. Well, cleans that off pretty quick. I'll let it soak for a few minutes. Yeah, definitely get some blue right away. All right, I'm gonna cycle this through a few times. Well, I may have hit on something here after soaking those pennies and cleaning them. And then after they dried, I just splashed a little bit of water on them. Boy, they got their verdigris really fast. Probably should put a time lapse on this. And look at that, those shiny ones are really starting to get some black copper oxide formed. So we are starting to see this at various stages of formation of the verdigris. Very interesting. Reaction went way too slowly to see it in real time, but with the time lapse you can see the hydrogen bubbles being formed, and especially on the screw you can see how it's darkening up, showing that the copper is precipitating onto it. A little harder to see with the aluminum at this point. Perhaps the solution is starting to clear up a bit too. Well, those really cleared up quite a bit, and there's no doubt that we can see that some copper is definitely formed on here. So the copper is plated out and the color is gone. Now, I don't know about the aluminum though. Problem is you get all these other crap in there. Let's take it out. Take a look at it. I don't know if you can see this, but it turns out there is some pitting on the aluminum. Looks like it could actually be the formation of a little copper, but hard to believe that that's enough to have cleared the solution, but we'll take it for now. This one seemed to be completely clean. But we'll see what happens when we use a much more concentrated solution. We don't see some copper coming out of that. Well, who knows what's going on. All right, I'm gonna try to filter this here. Get rid of some of the extra stuff. Eventually I figured out that using a funnel was a lot easier. Woo, by creek quick. Okay, so we're gonna go ahead and put this piece of steel in what looks like a fairly concentrated solution of copper acetate and copper chloride. And then we're gonna put this in there and a little aluminum foil and get that going. And now I'm gonna start the time lapse and let's see what happens. I can see now there's definitely some bubbles of hydrogen that I think are hydrogen are forming on the aluminum foil. Definitely expected this to go faster when there was a more concentrated copper solution. Let's see. Oh yes, you can definitely see bubbles forming here. Well, we'll see if we can get some copper to actually precipitate on the bottom here. Yeah, definitely can see some bubbles. Well, it's just been a few minutes and already you can see a copper coloring forming on the aluminum foil. The solution with the iron first turns greenish and then brown. It could be because of a lower concentration of copper ions. It could also be iron 2 ions before they're oxidized to iron 3. I guess I'll just have to research that more. Note that I had to add some more aluminum from time to time to keep the reaction going. Well, that certainly looks like a lot of copper down there. The solution really had looked pretty concentrated, but still surprised how much copper I got out of that. Pretty good amount. And I don't know what to make out of it. There still seems to be something copper. It's clear. I mean, that really looks like copper. But why and maybe there's copper at the bottom. It's hard to tell what color that is. Almost looks like a nice Kimoon tea. So well, I'm going to go and filter this stuff and let's see what happens. And try to do this without spilling it. I don't know, I hope so. There's a lot of copper there. All right. Wow, that looks pretty clear. I'd say we probably got all the copper out of there. Now for the other one. It's pretty coppery looking. Oh yeah. Yeah, that looks pretty good. Okay, well here's what we get with the aluminum foil. I mean, yeah, definitely looks like nice bright copper. After it dries, I think we're going to see some oxide and some other stuff though. And here's from the iron. That looks nice and bright too. All right, so after picking out some of the larger pieces of aluminum, I got a little bit of a haul of copper there all together. Not too bad, really. Of course, we have our aluminum solution, no surprise there, but this thing, what could be causing this color? Only possibility I can think of are the iron ions. Maybe some iron chloride or something going on here. Iron acetate? Don't know anything. Gonna have to look this up. So there's a iron 3 chloride solution on the left and an iron 2 chloride solution on the right. So I've got to assume that we're looking at some iron 3 chloride and some iron 3 acetate here. Okay, now I looked this up and it turns out that this very dark reddish brownish solution really could be iron 3 chloride, because that's what it's supposed to look like. So finally, we're going to see if we can precipitate out that iron using the aluminum. And at the same time, perhaps we'll see that the solution will clear up. Okay, so let's find out what happens. Well, here we go. This one took a really long time, and I kept adding more aluminum to try to make it go faster. I also added some salt from time to time in case that would help. But ultimately it did what it was supposed to do. Hydrogen bubbles were formed. The solution became colorless as the iron precipitated to the bottom. So it worked out. Well, I had to stop the time lapse because I had to go to bed, but overnight this definitely cleared up. Presumably there's some iron sitting on the bottom along with that extra aluminum. Okay, well, let's filter it out and see what we got. There's a whole lot of aluminum in here because I was so impatient. but we'll get most of that out of there once it dries. Okay, I've picked out some of the aluminum, and presumably we got some iron in there. However, it could also be oxidizing. It looks kind of red. So before it all does, I'm going to check to see if there's anything magnetic in there. Getting anything to come up here. Let's make sure it's not pressed into the paper. It's still kind of wet. That's the problem. Okay, so let's find out if there's anything magnetic here. So I got a very powerful magnet. Whoa! There's no doubt that this higher magnet, whoa. This really has to be reproduced. The material looks a lot like copper, and I can't be 100% sure that the movement wasn't being caused by the rubbing against the paper. So I'd really like to try this again. I know, it's weird how it works sometimes and not others. All right, let's get it all concentrated here. See what happens. I can speculate that the iron is oxidizing, which would make it lose its magnetism. I think next time I would try scraping some off the paper right away and testing the magnetic properties before the oxide could form.